This short video provides an overview of the Stratified Multi Criteria Decision Making method. This video also explains where and how this method can be applied to facilitate decision making. Let's start with a simple multi-criteria decision-making problem. Assume you want to buy a house and have 4 options. You want to decide which option is the best for you. Assume that you have 3 criteria for this decision. The first is the size of the house. The second is its accessibility to public transport. And the third is the price. Because you have more than one criterion for this selection, it becomes a multi-criteria decision-making problem, which is also referred to as an MCDM problem. How would you decide which option is the best for you? There are a range of multi-criteria decision-making methods that can be applied to solve this. Let's use a very general method. First, you need a scale to assign scores to options with respect to the criteria. We can use a 1 to 9 scale. If an option is extremely satisfying to you with regard to one of the criteria, it receives a score of 9. And if it is extremely dissatisfactory, it receives a score of 1. You assign scores to these 4 options with respect to each one of these criteria. For example, you need to decide how good option A is with regard to size and assign it a score. Then, you need to decide how good it is with regard to accessibility and assign it a score. Finally, you need to decide how good it is in terms of affordability and assign it a score. After you've assigned scores for the first option, you need to do the same for all the other options. By doing so, you determine the scores for all the options with respect to these 3 criteria. Next, you determine how important each of these criteria is to you. You compare these criteria and say, for example, size is 20% important, accessibility is 20%, and price is 60%. So weighings are assigned to these criteria. It is now easy to identify which option is the best. You need to multiply the weighings of the criteria by the scores, and the sum of the scores for each option represents its value. The option that has the highest value will be your best option, but in many cases, the problem is not this simple to solve. For instance, the above example related to the selection of a house to purchase. Buying a house is a long-term decision and will impact your life for a relatively long period of time. You might be doubtful about the weighings of the criteria. When you are asked to assign weighings of importance to the decision criteria, you may become concerned with things that may happen and which may impact the weighings of these criteria. Let's refer to these things that may happen as likely or possible events. One possible event may be the fact that you see yourself getting a promotion or a more highly paid job in the near future. If this happens and you get a more highly paid job, your income will increase. If your income increases, the importance of the price of the house, which is one of the criteria, will decrease. Under this scenario, you may not care as much about the price of the house as long as the other options are performing well with respect to the other 2 criteria. Now, you need to answer this question. If event A happened and you get the more highly paid job that you have in mind, what would be the weighings of the criteria? Let's say if this happens, the weighings of the importance for size, accessibility, and price will become 40%, 40%, and 20%. Now the case becomes interesting because you have 2 different sets of weighings depending on what may happen in the future. The question is, how should we consider such uncertainty in the decision-making process? This is where the stratified multi-criteria decision-making method may help. To assess these 2 situations, we consider 2 states. One is that your current situation persists and nothing happens. In this state, the weighings of the criteria remain as you initially assigned them at the beginning of this video. 20% for size, 20% for accessibility, and 60% for price. The other state is where your income increases and you have a more highly paid job. In other words, if event A happened. In this state, the weighings of the criteria change to 40% for size, 40% for accessibility, and 20% for price. Let's make it more interesting. Getting a better job is one scenario. Another possible scenario is that you have children or pets in the future. So we add a third state to represent a situation in which you have children or pets. We can refer to this as the occurrence of the second event, or event B. In this state, the weighings of the criteria become different again. This is because under this scenario, you may care about the size of the house more than you did before. Let's say the weighings under this scenario are 40% for size, 25% for accessibility, and 35% for price. To make this example more interesting, let's add a third scenario. Assume that you currently have no driving license, but you may decide to get a license and buy a car. You are still unsure about this. To consider this as well, you can add another state in which you see yourself having a car. In this state, the weighings of the criteria of accessibility to the public transport loses value because under this scenario, you would have a car and you would not care as much about public transport. Okay, now we have 4 states. The first state represents the no event scenario, or in other words, if nothing happens. State 2 is when you have a more highly paid job. State 3 represents the situation in which you have children or pets. And State 4 represents the situation in which you have bought a car. The next step is to find out how likely these events are to happen. This is not always easy, but you can do some research to help you estimate the likelihood for each state. For example, assuming that you are currently an associate professor, you do some research to find out the job qualifications you need or selection criteria you must meet to be promoted to become a full professor. You may have a look at similar jobs which have been advertised and see how well qualified you are to get such a job. You can also talk to those who have such jobs to arrive at a more reliable estimation. Remember that even if this likelihood is not very accurate, considering a state with such a likelihood is much better than ignoring these states altogether. Anyway, you can estimate the likelihood that you transition from the current state or state 1 to state 2 in which you have a more highly paid job. Let's say you find it to have a likelihood of 40%. You may feel uncertain about this likelihood, but don't worry, the Stratified Multi Criteria Decision-making method can be developed on a simple Excel sheet. So, in the future, whenever you find that this likelihood is different, for example, instead of 40%, it is 20%, you can easily change the input and the optimal values of the ranked options will change. Let's go back to our example. Now, you can do similar with regard to state 3 and 4 to find out how likely these states are to represent the future. For example, you may talk to your partner to estimate the likelihood of state 3, and you may check with the institution that issues driving licenses to obtain more information about the requirements. You can also check the track record of your savings and also check the price of your preferred car to see whether you'll be able to buy it in a foreseeable future or not. Let's say you estimate a 15% likelihood of having children or pets and a 60% likelihood of buying a car. You also need to estimate the likelihood that your current situation or state 1 persists. To say it differently, you need to estimate the likelihood that none of these events happen. Let's say you see this to be not very likely, and therefore assign it a likelihood of 35% to state 1. Now, you have the weighings of the criteria in different states, and the likelihood of transitioning from state 1 to states 2, 3, and 4. Now, let's stratify these states. State 1 is placed in stratum 1. Then, by taking one step, you can reach the second stratum, which includes states 2, 3, and 4. This is not all. You can also transition from stratum 2 to stratum 3, in which two of these events happen together. For example, state 5 represents the situation in which the first and second events both happen. To say it differently, state 5 represents the situation in which you get a more highly paid job and you also have children or pets. State 6 represents the situation in which you get a more highly paid job and buy a car. State 7 represents the situation in which you have children or pets and you also own a car. You need to assume the happening of these events together and assign weighings to the criteria. There's also another stratum to consider. These three events can also happen together. This creates the last stratum, or stratum 4. This stratum only includes one state, which will be state 8. So, state 8 represents the situation in which you have a more highly paid job, children or pets, and a car. The next step is to estimate the relative probabilities of these states. If these events are not independent, you need to estimate the likelihood of each of these states in the third and fourth strata, and then we proceed with the next steps. But to make it more interesting, let's say these events are independent and do not have a significant impact on each other, meaning that having a higher income will not impact the likelihood that you adopt pets or have kids, or even if it does, the impact is not significant. With this assumption, we can say that the transition probability for each state is a multiplication of the events that create that state. For example, the probability of state 5 is the multiplication of the probability of event A and B. So far, we have the likelihoods of the events, but we do not have their probabilities. But we can compare their likelihoods in order to compute their probabilities. As explained earlier in this video, we already have the likelihood of occurring no event, event A, event B, and event C, which are 35%, 40%, 15%, and 60%. The relative probabilities can be computed by comparing these likelihoods. The likelihood of the occurrence of event A or transitioning to state 2 is 40%. The likelihood of remaining in state 1 is 35%. So, transitioning to state 2 is 1.143 times more likely than remaining in state 1. Similarly, transitioning to state 3 and 4 are 0.429 and 1.717 times more likely than remaining in state 1. Now we have the probabilities of the events based on the probability of remaining in state 1. So we can compute the transitioning probabilities of all states based on the probability of remaining in state 1. As mentioned earlier, these three events are independent, and therefore the probability of each state is the multiplication of the probabilities of the events that create that state. So, for state 5, the probability of event A is multiplied by the probability of event B. Similarly, we compute all probabilities based on the probability of remaining in state 1. We know that these are all possible situations and the sum of their probabilities needs to be equal to 1. This means that we have an equation to solve. If we solve this equation, we can compute all the probabilities. Solving this equation is easy. We can use an online calculator for polynomial equations. Using one of the weblogs that offer such services, we find the probability of state 1. Because we have already compared all probabilities with the probability of state 1, we can now compute all probabilities. Now we have the probability of the occurrence of each state and the weighings of the criteria in each state. By multiplying the probabilities by the weighings and summing up the resulting values, we can find the optimal weighings of the criteria. This is the same as finding the result of this matrix multiplication. Now we have the optimal weighings of the 3 selection criteria. We can identify which option is the best. It is easy to do this. The scores were already assigned to the options with respect to these 3 criteria. We only need to multiply the optimal weighings by the scores and compute the sum of the scores for each option. Now the value of each option is computed. What we need to do is select the option which has the highest value. At the end of this video, I need to state that the Stratified Multi Criteria Decision-making method was proposed in 2018, and it is fundamentally based on the concept of stratification. The concept of stratification was initially developed in 2016 by Professor Lotfizadeh. For more information, a few references have been included here. I hope you enjoyed this video. If you found this video interesting, please help by sharing the link to reach a wider audience. Thank you.